Everyone, are you enjoying the conference? Great. So this morning we would like to share with you some of the things we do at Redis Labs. So our primary goal with developing Redis Enterprise is making Redis a primary database for enterprise use. Now, this is an ongoing effort which is done in three main buckets. The first one is adding more functionalities, more capabilities, more use cases to Redis. The second thing is around operational enhancements to the database so it becomes more fit to the demanding requirement of IT departments of enterprises. And the third is around economic flexibilities, which means we would like to make Redis more affordable to anyone. Today, we would like to share with you some of the results of this ongoing effort from the last year. And we will start with running Redis Flash in a database as a service model. So, database as a service is not new to this company. Moreover, we started, our first product was a database as a service product, which was called and is called Redis Cloud. And in this product, we provide a fully managed service for Redis on servers that we rent in major public clouds, such as AWS. About a year and a half ago, we introduced another service which is called Redis Cloud Private, and this is basically a fully managed Redis service within private environments of our customers on the cloud, within their VPCs. Both services are supposed to be zero touch, except that Redis Cloud Private until recently was basically provided in what we call a reserved model, whereby we did the onboarding of the customer. So today I'm happy to announce that Redis Cloud Private is available now in a self-service model, whereby anyone can go to our website, sign up, create a subscription, create a database, and everything is fully automated without any human intervention. Moreover, we talked a lot in this conference yesterday, and we'll talk more today about Redis on Flash. So Redis on Flash so far was available with Redis Pack, which is our downloadable software. Let me, before we talk about Redis on Flash with Redis Cloud Private, let me remind our memory, what it is all about. So the basic idea with Redis on Flash is to cut down the deployment cost of Redis. RAM, as we all know, is very expensive, and this was always, we thought, a hindering factor for wider adoption of Redis. Now, with Redis Flash, we use a little RAM and a lot of Flash. RAM or Flash is used as RAM extender, so whatever we put on RAM, we do not put on Flash, and vice versa. Just that you know, Flash is not used as persistent storage, because when you operate on the cloud, if your node is down and you recover later, you get an empty node, so Flash won't help you. So in any case, if you need persistence, you'll need to use network-attached storage. So the idea is to use like anywhere between 10 to 25% RAM and all the rest Flash. And with that, we were able to get a performance which is still under 1 millisecond response time on average. Throughputs are somewhat lower than RAM, but still good for most use cases of Redis. And the nice thing about it is that you start with 10, 15% RAM, and you look at your performance. And if you are not happy with that, we have in our user interface, we have this slider which you can move a little bit to the left to add more RAM, and that will immediately get you more performance. Now, when you do that, the system will automatically, behind the scene, add more RAM resources if needed. As you know, memory technology is developing very fast, and this is a very good backwind for Redis Flash. So in this slide, you see some of the new technologies in a comparison manner. So the right vertical axis is the response time in microseconds, and the left vertical axis is the cost per gigabyte. And on the left side, the left bar is RAM, which is $9 per gigabyte, and the response time is 0.1 microsecond. This is obviously the best. On the right side, you have the traditional SATA-based flash SSD, where the cost is $0.4 per gigabyte, and the response time is anywhere between 250 to 500 microseconds. Then if you move to the left, there is NVMe SSD, which is now available on most clouds. This comes at a cost of approximately $1 per gigabyte, and in terms of response time, it's anywhere between 25 to 100 microseconds. And the newer technologies, NVDIMM, will come at approximately $2 per gigabyte, and the response time is an amazing 1 microsecond, for this one. Let's look at some of the announcements of last year in this area. So Google announced the new NVMe-based local SSD, which you can attach to any instance on the Google Cloud. Amazon recently announced their i3 instances, which come with NVMe technology. We did a few benchmarks on that technology, and what you see here are the results. So basically, we compared the SATA-based i2 instances with the newer NVMe-based i3 instances. We ran Redis on them, and as you can see, by the way, we have two types of i3 instances. So the orange one is a smaller one, and the gray one is a larger one. And as you can see, the vertical axis here is throughput in transactions per second. And obviously, when you switch from i2 instances to i3 instances, performance gets much, much better. Then IBM announced their new Flash GT card, which can get several NVMe setups. And Intel announced their new 3D X-Point chipsets, which are now available, and we also tested those. And what you see here is a benchmark of this Optane SSD compared to i3 NVMe instances. And this, again, is ops per second. The vertical axis is ops per second. The blue bars are the Optane NVDIMM chips, whereas the red thing here is the red bars are the i3 NVMe instances. Yeah. So what you see here is basically Redis Cloud Private running with Redis Flash. And we are talking here about a 2 terabyte data set, whereas approximately 25% is on RAM and the rest is on Flash. 85% hit ratio and 1-to-1 read-write ratio. And as we can see, it's very stable around 300,000 ops per second with latencies which are well below 1 millisecond. And this, ladies and gentlemen, is available now in a self-service mode on the Redis Labs website. So, in terms of cost, I would like to show you a cost comparison of Redis Cloud Private with Redis Flash compared to some of the other Redis services and other database as a services offered on the cloud. So we will start with the second from the left, the red bar, which is Redis Cloud Private running on RAM. And the setup for all these services is the same. We are talking about 2 terabytes of data set with high availability, 100,000 ops per second, and all prices here are on-demand prices. So it's not reserved or anything like that. So Redis Cloud Private on RAM would be, with these requirements, would be 1.7 million per year. To the left of it, the blue bar is another Redis service which is offered on the cloud. This one goes for $2.2 million with the same requirements. Then, if we move to the right side, which is the light gray one, so this is another database as a service on the cloud, which is not Redis, by the way, which runs on Flash. As you can see, since this particular service does not use RAM, it's only Flash, the performance is not as good. We are talking about 10 millisecond on average response time, but the cost is better. It's $700, like $0.7 million per year. And then the most to the right is Redis Cloud Private with Redis Flash. And this one still will give you the under 1 millisecond average latencies with approximately $0.2 million per year. So we are looking at 89% savings. And, all this is currently available for everyone. You can log in to the Redis Labs website, sign up, and create your own database on this. Yiftach.
Thank you. This one. Okay, I would like to speak about modules. How many of you have heard about modules? Great. So, we launched modules a year ago, and I would like to give you an overview of what happened since then. So about 50 modules were created. So we really feel we create like an in-memory database platform here that you can create a lot of modules to solve your problems. Modules can now be written in Go and Python, not only C or C++. And I think the latest enhancement that Salvatore discussed yesterday is extremely important, and let me give you another point of view why it is so important to have multi-threaded modules. Now, unlike typical core database, core Redis operation, with modules you can create a very complex queries that run like 100 millisecond latency. Now, if these queries come in front of the regular core Redis queries, what happened is the famous head-of-line blocking phenomena, that the latency of the heavy request or the light request inherit the latency of the heavy request, and you can do your math. And in this case, even if the core query is 0.1 millisecond or 100 microsecond, it inherits the latency of the heavy query. Now, if you run a multi-threaded modules, like this one, so the 100 millisecond module query will run separately, and the core Redis request will go directly to Redis, meaning the average latency will remain at something like 0.2 millisecond for the core Redis. This is why it is extremely important enhancement, and this is why we decided to delay the version until this is inside. Now let's talk about 4 useful modules that are going to be available with the Redis Enterprise once Redis 4.0 will be available. Let's start with Graph. So have you noticed that today you can do something like that with Redis Graph? So this graph describes friends, friend of friends, and the visited countries that everyone were. Yeah? Now you can do things like that with the data structures that you have today with Redis. But the more you do things like that, the more complexity the infrastructure become. And in addition, if you want to do query like, give me the friends that visited the places where I've been to, it is very hard to do it with today API of Redis, and with the new Cypher-based query language that we developed, you can easily do it like this. So when we run it, you get something like this, which is nice. And you can even run another query that says, who has gone to a business trip, not only a pleasure trip? And the differences between this and the previous query is that this query runs on the edge. It's not only run on the nodes. Yeah? And again, this is the result of this query, taking into account the first graphs that I showed you. What is more interesting about these graph modules, it runs very, very fast. You can do something like 150,000 inserts per second per shard. And if you run these complex queries, you can get something like 15K ops per second with this, which is very, very nice. And we have a deep dive session about Redis Graph today at 2:30, so you are invited to see more demos regarding that. Let's discuss Redis ML in a nutshell. So everyone is speaking about ML. ML in general has 3 phases. You train something, you create a model, and then you serve this model. But everyone on Earth really focus on the left side. How do you train the model? But practically, just a few are discussing how you serve the model. What it means to serve the model, it means how you serve the app, the ads, for example, or how you drive the card. And this problem is not so easy to solve. First of all, there is accuracy issues, okay? If you are ads company, you don't want to see something like this. Yeah? You don't want to put the wrong ads, which is out of context of this article. Yeah? Now, in order to do that, let me give you a real-world example. There is an ad-serving company. They need to serve something like 20K ads per second. This is, normal use case. Everything needs to be under 50 millisecond latency. Again, this is normal cases. And they run something like 1,000 campaigns simultaneously. Now, if you map this model to what is called random forest, which is a relatively complex model, okay? And you do all the math behind it, and we have a session that describes what is random forest, et cetera, et cetera. But if you want to be really accurate, you reach to something like 1.05 trillion operations per second. This is huge. If you run it on AWS, do the math yourself. This is over 1,000 server, the expensive server. It's about 11.5 million reserved instances per year. Now, if you run everything with Redis Enterprise, you can cut the cost by 97%. And the main reason is that the Redis ML was built to serve complex modules. And more about this will be in the next session that the Databricks guys are giving. And also where we have a dedicated session today that speak about Redis ML. Let's move to the next interesting module. Read JSON. So there is a famous saying by the guy named Jeff Hadwood that said, any applications that can be written in JavaScript will eventually be used JavaScript or be written in JavaScript. This is well known. And the implication of that is that every database will eventually need to have something in JSON inside it. And the truth is that when we surveyed our customer, we found out that the #1 request is to be able to run native JSON on the top of Redis. And this is exactly what we did. We created read.json in 5 words. This is intuitive, it's integrated, it supports any client, and it is extremely fast. If you compare it to what we had so far, this is about, 70, 50 times faster. If you are talking about nested operation. So this is the beauty about ReJSON. We had a session about it. If you find Itamar here, he can discuss with you in private about it. Let's move to the next. Redis search. You know, about a year ago, when we first launched the modules, we show initial benchmark about the Redis search and how fast it is. But this was just an experimental use case. Now, throughout the year, we understood that in many, many cases, you need to search fast. And I'm not talking about searching in logs. If you want to search in logs, go and use Elastic. It's a wonderful tool. Or Solar, this is also a wonderful tool. But if you want to search like this, there is need to be something else. And this is the benchmarks that we did a while ago. It runs over the Wikipedia data. It shows that when you search for Barack Obama, you get something like 5 times to 10 times faster than any other search engine. By the way, we just completed another benchmark. We ran over a Russian cloud, and we searched for Trump. And the performance was much, much higher. This is a joke, by the way. There is no cloud in Russia. Yeah? So Redis search is not only fast, it's a very free, it's a feature rich. So you can do full indexing with multiple fields in the document. You can do complex Boolean queries. You can do updates behind the scene without hurting the performance. And maybe most important, you can do custom search. So this module itself allows you to add your own modules and to add custom search. Now, another very interesting stuff that we did with Redis search is the way the shards are constructed. So you have the Redis, of course, and you have the Redis search modules that run on the top of it. But in addition to that, we have a coordinator. And everything creates this Redis search shard. Now, if you look at, for example, this kind of cluster, the way it works is that you get a request for a search. The coordinator part of the Redis search fan out the request to all the other shards in the cluster in a way that, you know, up until now, we didn't use in Redis cluster. So we didn't use to talk between shards. So with Redis shards, you have this capability. Now, if the cluster becomes bigger, like this one, we do the fan out differently. We do a tree-based fan out in which we only send to one other coordinator in each node, and these nodes forward the coordination to other shards. Now, with that in mind, let me show you for 1 minute how this runs live. Okay, so this is Redis search benchmark. By the way, I must give him a credit. Search was created by a guy named Dvir Volk. He could not come today because his wife just gave birth, but he did this wonderful job. And as you can see, we are now indexing in runtime the Reddit stream, the Reddit content. And this is about 100,000, 90,000 index per second. And we can simultaneously search for Redis, yeah? And see the result. Moreover, we can simultaneously do a benchmark that do search in addition to the indexing part. And as you can see here, it's run about 10,000 searches per second. This is much faster than anything you know in the industry. Just to show you that this runs live, this is a 9 nodes cluster with 100 shards. I don't have time to dig into that, but this runs live, and I think it is amazing.
So next thing is Redis for IoT. So with certain things that were done recently, especially Stream, Redis is slowly but surely becoming the optimal database for IoT, and let me explain why. So as you know, the number of devices connected to the internet is expected to grow very nicely, as you see in this chart. However, most of the growth is coming from IoT devices and not from humans being connected to the internet. Now, when you talk about IoT, you typically talk about a 3-tier architecture where you have devices which can be, switches or, machines or anything like that. at the very end. Then you go to the edge tier. The edge tier is some sort of concentrator and is connected to multiple devices. And then you have the cloud where everything goes to be analyzed, etc., for further use. Now, the device itself started as simple devices like switches, very simple sensors, etc., evolved into a more complex, intelligent devices. And now we are talking in the industry about devices with memory that will be able to log activities even if the device is down. So later on, when connection is restored, you'll be able to, you will not lose data. Now, how is Redis connected to all that? So we think that Redis can be an excellent database for all three tiers, starting with the device. So on the device, we look at Redis open source as an excellent solution. Redis open source has a very low footprint, 3 megabytes only, can run easily on Raspberry Pi, ARM, etc. And with the Redis Stream client, it can very easily take care of transferring data between the device and the edge, and also take care of what happens if the device is offline. And obviously, the cost here is very attractive. No cost, actually. When it comes to the edge devices, so basically the industry is talking about a small form factor cluster. So we are talking about nodes with 4 cores, 1 to 2 gigabytes of RAM, and 50 gigabytes of flash. And the requirements here are that such an edge device setup can easily support up to 20,000 end devices, each with like 10 updates per second. So all in all, you are looking at about 200,000 updates or transactions per second. Then you need clever or smartness or added functionality to the edge, because you would like to do things like time series, search, maybe graph functionality, obviously some machine learning functionality at the edge in order to screen some of the data and not transfer everything as is to the cloud. And of course, it has to be very simple and reliable, because it may be dispersed in many locations, some of them remote. So when it comes to Redis, we are talking here on the edge level, we are talking about Redis Enterprise, which can run on x86 or Raspberry Pi machines. We are talking about using it with Redis Flash. It will have persistent and high availability, and of course it will have both stream server to get data from the devices and a stream client to send data to the center. And you can select from numerous modules like search, JSON, graph, time series, ML, and so on for the smartness or the intelligence of the edge device. And last, of course, is the cloud. In the cloud, you can use larger clusters of Redis Enterprise with Flash. It can be database as a service. It can be standalone software. It can be on a single cloud, multi-cloud. It can be single master, multi-master, etc., etc. Now, the beauty of using Redis in all three tiers, or at least on the device and edge levels, is that, first of all, you have the same API. The developer has the same API to the database in all levels. Secondly, with streams, it becomes very easy now to build an end-to-end IoT systems where if anything goes wrong and one of the levels, one of the tiers is down, once connection is restored, Stream will automatically take care of, updating all the levels and making sure that all the data was transferred. Now, we are talking to some of the platform providers of IoT, and we are having very intensive conversations in making Redis a database of choice for their platforms. But I urge you, the Redis community, to look very seriously, if you have IoT cases, in incorporating Redis as the database for device, edge, or cloud levels.
Last paragraph for today. How many of you are looking for a multi-master solution? Okay, so during the last 2 years, we have been looking to find a solution that is really fits to Redis, but also solve the very difficult problem of multi-master solution. And we examined something like 100 cases. And in general, you can divide them to 2 main cases. On the left side, you see this is an holistic database. It runs across multiple regions, but people are writing and reading to different parts of the data set in different regions. So practically, there is no conflict, unless someone is using a mobile device and the DNS that route it to the data center switch it to another data center. And this is the left part, and then he should be able to read and write, continue reading and writing to the other data center. So for example, profiles, or example, session management. On the right side, there is, I would say, more modern use cases in which you want to run something like a bidding or leaderboard across the world, and everyone is writing and reading to the same data set and in geo-distributed manner. Now, what is the challenge here? We all use Redis, and it is very easy to create a Redis today that runs 100 million operations per second and some millisecond transaction. But the speed of light is slower. If you think about it between the US East and the US West, the round trip of the speed of light is over 20 milliseconds. If you add the network latency, it's even over 70 milliseconds. Why it is even important here? Because if you want some level of consistency, it doesn't matter if it is a strong consistency or eventual inconsistency, you need to have consensus. You need to have consensus between the majority of the replica to decide which value is the right value in your data set. And consensus are slow because you are depending on the one latency. The other challenge is how you deal with conflict. So many people thought that dealing with conflict at the application level is easy, but it is not easy. It is completely complex, and in addition to that, it is also very, very slow. Now, if you use the traditional last right win approach, it can use for some use cases, but in many, many of the data types of Redis, it just doesn't fit. So it doesn't fit to counters, it doesn't fit to set, it doesn't fit to sorted set, and I'm not talking about even the advanced data structure of the modules. Luckily, a group of very smart professors about 10 years ago created what is called CRDT. CRDT stands for conflict-free replicated data types. And now, after years of researches, they practically created a very robust technology that is based on consensus-free protocol. That means I don't need to speak with the other replica in order to converge my value to the same value. And this is what is also called strong eventual consistency. So everything is eventual consistency, but the strong part means you don't need a consensus protocol in order to converge the values. And it's also built to solve the conflict of complex data types like in Redis. And what we have done during the last 18 months, I would say, is that we map CRDT together, by the way, with a few of the creators of this approach to Redis. In a way that if we look at this deployment, we create a cluster in 3 regions in this example, but this is an independent cluster. It is not one cluster that span across the world. These are independent clusters. From the application perspective, this is a local write. So it's sub-millisecond latency. And behind the scene, there is something that converges asynchronously in a magic way, so the application doesn't need to deal with them. So this solves the latency problem, but I didn't show you how we solve conflict, yeah? Now, with conflict, which is a very difficult stuff to discuss, first of all, we need to see that there is a conflict, that operation happened concurrently. And concurrently doesn't mean that it happened in the same millisecond. Who says that the clocks are even sync? So I won't deal with concurrency, and it includes vector clock, and this is a bit complex. We can discuss it later. But let's assume that now I'm discussing about concurrent operation. And what's the beauty of CRDT is that it deals differently with any data type of Redis. Let's start with counter. So all the replica has 500 in there as a value, and replica A increase it by 200, replica B decrease it by 300, and replica C increase it by 1,000. What will be the convergent function? It will take the 500 and sum all the effects, all the changes. So all the replicas, once they get all these effects, will converge to the same 1,400 value. This is how counter works. It looks like something very trivial. Let me show you another relatively trivial example. Set. We have A, B, C. Someone in replica A add D. Someone in replica B add A. It doesn't change the set, because if you add an existing value, it doesn't do anything, but it's a legitimate operation. But someone in replica C delete A. The convergent function will take all the effects, and it will use the terms in CRDTs that add wins. Okay? So it will prefer the ones that added A on the ones that deleted A. If we want to look how sorted set works, it's a combination of counters and set. And if we want to look how list works, this is just too complex to show you now. But now it's the time to show that this is a working technology. And let me introduce Gian, our VP of product, to show you a very nice demo.
Yes. All right, I'm on. How are you guys doing? Excellent. Ooh, yeah. All right. So I'm going to show you how, I know there are a lot of acronyms, and Yiftach described a lot of the technology behind this. I just want to show you how easy it is to build sophisticated geo-distributed applications with CRDTs. And when I say easy, I mean really, really easy. What I mean is your marketing department can write this code. I love you guys. I just like to open up with offending some people. You know, it's always a good open. Anyway, let me set the stage. The app that we're going to look at is a social app. We're going to do opinion polls. We're going to run many opinion polls on the site. You're going to see a lot of load. We've got users distributed around the world. So we've got some users in the US doing polling and voting for things that they actually like. We've got people in Europe voting for things. So you're going to see all of this load that's going on. Now I'm going to slice through this application. I'll show you the layers of it, but we'll take a look at the geo-distributed setup. Then I'd like to show you the Redis enterprise cluster that's running behind the scenes and running all the operations. I'll show you what the app looks like. We're going to show some real-time results directly to the end users who are voting. And I'll tell you what the developer had to do to write all of this code. So that's the way we'll actually go. All right, let's kick off some load. All right, so this is the West Coast users. What they're doing when they log into the site, the million operations, over 1 million operations that you see here, what they're doing is they're coming in, and we track two things about them. What are they looking at? We track the number of views that they've actually, the items they've received, and then we'll track the things that they're voting for. So the 1 million operations that you're seeing, well over 1 million, is also being performed in less than half a millisecond of latency here. So all you see right under the bubble is the local workload. As I said, we've geo-distributed the application, so let me kick off some additional load. Actually, let me show you what the cluster looks like right about now. All right, so this is actually a fairly small cluster. It's 3 nodes, 4 shards, and let me show you the stats that are going on. So the 1 million operations over second, right here at the top, you see the ops per second and the latency. Right, this is going on, and this is a real deployment. So we've got the other geographies as well. Let me kick off some more load. So what I've just done is allowed the East Coast users to start voting on the opinion polls as well. Not only are these clusters doing their local work, they're also reconciling the results that they actually have from other clusters. All right, let's do one more, and that's Europe. So we're above 4 million operations per second at this point, and we can tackle this. And this is all built on CRDTs. All right, so let me click directly into one of the polls that's going on. So we're going to be seeing this real time. We're going to be voting for our favorite alien. So Yoda, my favorite planet Pandora. So H here is there. And the guy with some anger management issues, Xenomorph, is there. So let me kick off the views over here is what we're actually looking at. So you'll see each one of these bars under Yoda is representing the geographies and the views that we're actually getting from them. Now, Yoda, the red bar is the West Coast, the blue bar is the East Coast, etc. The problem, which Yiftach touched on, is we have views in Europe, we have views in the US, but if you got 100 views in Europe and 10 views in the US, you don't want the result to be 100 or 10, you want the result to be 110. So what we actually do in this case is we use a string, a counter, with an increment operation. And all the developer has to do is just basically, in each geography, every time somebody looks at Yoda, go to the Yoda views key and do an increment operation. What CRDTs allow us to do is to understand the developer's intent and correctly replicate the information across sites so that your counter doesn't get picked on one side or the other, but it gets accumulated over the tree. Now, votes, very similar. We use sets for this. We want to track the profile of each one of the voters. We want to see what they're voting for. We also want to prevent duplicates. So we use the sets, and all the developer has to do, again, is just do an add every time somebody votes for Yoda, for the key that is associated with that item. In a system where CRDTs don't exist, you obviously would have many people voting for Yoda in Europe, many people voting for Yoda in the US, but you would have to pick one of the two. So last right wins doesn't work, but CRDTs can actually simplify this a lot. All right, so I'm going to stop the load. What we expect to see is all three clusters to agree on a final result when I close this poll. And you can see that the lines flatten and the clusters converge very quickly on this poll. And most importantly, Yoda, the good guy, is the winner.
Yes.
Thank you, thank you. So the point I want to make is CRDT simplified developing these sophisticated, complex, distributed applications much, much simpler. If you're developing fraud detection applications that are capturing distributed events, if you're doing distributed metering applications or scoreboards or dashboards that are capturing events in different geographies, if you have social timelines that you're constructing, a smart timeline that needs to converge, or a group chat application that needs to correctly display the conversations that are happening in real time, CRDTs is the best way to do that. With that, I'll hand it back to you.
Thank you, Gian.
Thanks.
Very impressive. So, you know, just to complete it, there are a lot of stuff that we did behind the scene in addition to CRDT. I won't get into that, but thank you for the demo.
Yeah. So this is it for today. Also, we ran out of time, but we are not stopping here. As I said, the goal is making Redis Enterprise the primary database for enterprises. So stay tuned. We are continuing. Thanks very much.